Hello, everybody. Welcome to the last session of Virtual FoxFest 2024. Thank you for sticking around for the last session of the day. Today, we're going to be talking about working with flat files in Visual FoxPro. My name is Rick Borup. After spending several years in corporate IT and the retail banking industry, I formed my own company in 1993, about the time I got seriously excited about FoxPro. And I've been working with FoxPro and a little bit later SQL Server, almost 100% of what I do now in those past 31 years or so. Back when certification was a thing, I was able to pick up a couple of certifications in FoxPro, and I had the opportunity to work with some really smart people and co-authoring a couple of books, in addition to white papers and conference presentations. So I'm really thankful for the community that we have and the richness and the sharing that goes on in our community. Here's what we're going to be exploring today. First of all, I want to talk about what flat files are in the context of this session. And then the session, most of it will focus on importing into and exporting from flat files in a VFP app. We'll spend some time talking about how we can parse the strings that we get in after we read a string into Visual FoxPro from a flat file. And in the context of that, we'll spend just a couple of minutes looking at dates and numbers, which can, in many cases, require special handling, and you have to be alert to what you're getting in the input file. And finally, I want to close up by mentioning Excel. Excel is such a widely used product. Users love it. They keep data in it. Sometimes that data is given to us for import, usually in the form of CSV files, and that can be problematic. So the mantra is Excel is not data. I'll qualify that a little bit when we get to that part of the presentation. Everybody's remote today, so please use the chat window. There will be a Q&A session afterwards. I'm going to ask that we defer questions until the end. In rehearsals, this session ran right up to the last minute, but I'll monitor it as we go along, and if we have time, I'll ask for questions in the middle. Otherwise, please leave them to the end. So let's get right into it by talking about what flat files are in the context of this session and the way that I'm using it. In a flat file, all data are represented as strings. There's no binary data. Generally, the fields are delimited in some way, and if you look at a flat file in a text editor, that structure is typically visible. Either it's comma delimited or using some other character to delimit the fields. Sometimes they're surrounded by quotes. Even in a more hierarchical format like XML or JSON, the structure is easy to see, easy to understand. In simple files, it's even possible to edit or manipulate the data using a simple text editor. Flat files are most often used, in my experience, to exchange data between different systems. So you have a FoxPro application on one side, you have something else on the other side. You want to pass data in between, and a flat file is often the lowest common denominator for doing that. That's sometimes referred to as electronic data interchange, or EDI. One of the most popular ones, at least one that I'm familiar with in a lot of detail, is the Banking Systems Automated Clearinghouse, or ACH. There are many different EDI formats. Most of them are industry specific. And if you've been exposed to those, they're very formally defined, and you can program to that formality, to that specification if you need to work with one. The good news for us as Visual FoxPro developers is that FoxPro is really excellent at working with flat files because of the low-level file functions and because of the string manipulation functions that we have. It's great to either import or export. We have almost full control over anything that we might want to do. Some of the common flat file formats, and some of the ones I'll be talking about today, comma separated value may be the most common. That's what you get if you export from Excel, or at least one of the options if you export from Excel. Delimited files can have any of a number of different delimiters. Tabs and pipes are perhaps some of the more common ones. I've seen tildes and asterisks. It really doesn't matter. That's just the character that separates the fields from one another. where each row of data, each line in the file is one row of data. There's a file format called system data format, in which all of the fields are a fixed length. So that's a little bit different. There are no delimiters. It's just the length tells you where the differentiation is. And finally, hierarchical flat files like XML and JSON. As a quick example of what they look like, CSV, again, separated by commas. Usually it would have a header line. I'm not showing that here, but there are CSV files in a more generic sense of the term CSV that do not have a header line. The primary distinction is they're separated by commas, and either all the fields or at least the ones that could have embedded commas are surrounded by quotes. The delimited files simply look like this. I'm using the double right pointing chevron in this session to indicate the tab character. If you look at a standard definition or a system definition format, system data format in an editor, you're going to see spaces and things are going to line, the beginning of each field is going to line up, not necessarily the end, because there's an implicit delimiter between the fields based on the length of each field. XML and JSON have their own different delimiting characters and a little bit different structure, but still they're all strings. So I'm going to treat them as flat files in the context of this presentation. A quick word about line breaks. If you are working with different platforms, if you're either receiving or probably more importantly, if you're exporting and creating files that'll be consumed either on a Mac or a Unix system, you need to be aware that the line break is different on all three systems. Windows, of course, uses both carriage return and line feed, 0A or char 13, char 10. Unix uses only 0A and Mac uses only 0D. So that can be a consideration, and we'll see one example when we get to exporting where that can come into play. So let's talk about importing data. This is the challenge we face if we are tasked with consuming data that is coming to us from an external source in the form of one of these types of flat files. And our job as a VFP developer in charge of an application is to bring that into a cursor so that we can manipulate and work with it the way we would work with data normally. One of the more powerful built-in commands in Visual FoxPro is the append from. That's the one that I use most often. Later we'll see how to roll your own. But the append from command adds to an existing table or cursor, so that has to exist. Either you create one from scratch or you are working with one that's already there. The append from command is quite comprehensive. It can handle many types of files, but not all of them. And one of the limitations is that it can't not work with any of the newer Excel file types. There is a clause in the append from command that I want to highlight, and that's this one. It's the delimited clause. This one can be a little confusing, so I'm going to spend a few minutes explaining what it's all about. And even the help file description gets a little confusing when it uses both the terms delimiter and the term separator. You can see right here that the word delimiter shows up twice, and they actually have different meanings, especially if you're using both at the same time. So let's parse that out and take a look at that particular clause of the append from command. You have the with delimiter, and then out to the far right, you have the with character delimiter. That's not super clear just on the face of it, what's going on. So the way I have chosen to think about it, and I hope this is helpful for you all too, is that the first one is what encloses the field, surrounds the field. That would be the quote marks, for example, in a comma separated value file. The second one is what I'm going to call the field separator. That's the thing that exists between the fields to separate one from another. So if we look at an example, and by the way, we'll be seeing this particular data and a couple of other rows similar to it throughout the entire presentation, representing 7 fields in an order history with a date, an item number, a description, price, quantity, and so forth. In this example, the field is delimited with quotes. So it's a pretty standard CSV file. The files are separated with commas. By way of comparison, if we look at a pipe delimited file, the fields are separated with pipes. They are not surrounded by pipes. There's no leading pipe. There's no trailing pipe at the end. But there's a pipe character between each field. So that's the separating character. In this case, there's no field delimiter in the sense that there's no quote marks that are needed to surround, for example, the description, even though it has an embedded comma. The quotes aren't necessary in this case. They're not part of the specification for pipe delimited. And the comma makes no difference because in this case, it's not a separator. So let's look at some examples of this. And I'm going to flip back and forth to FoxPro frequently in this presentation. So we'll hope that all works out. And we'll look at some code here. And I need to go back to the top. What I'm going to do in each of these examples is show you the file that we're working with. So here we're importing data. I'm going to show you the file that we're importing from. In this case, it's a CSV file that has the header row and 2 rows of data. And we can simply use the type CSV that's built into the append from command. And that's all we need to do in this case. So if we run this chunk of code, we'll create a cursor.
We're still seeing the slides.
I don't know why that is. I'm sharing that screen. Why would it not be showing the screen? It's on the same screen. I don't know what to do about that. You are not seeing the visual file.
We're just seeing. Are you sure you shared the screen, not the window?
Yes, let me go back to that. Can I come out of this now? Would that be the thing to do?
I would stop. Yeah, I would turn off sharing and turn it.
Okay.
Okay.
Is that
there
better?
We go. Yep.
Okay. Apologies, folks. That was my mistake when I was getting set up here. So again, we're looking at the code window now. I was going to show you the file that we're importing from. Again, just a CSV file with a header row. And when I run the code using type CSV here, that's all we have to do to make this work. And the result in the cursor looks the way we expect it to. So everything's fine there. Similarly, with a tab delimited file, that's one of the known types of files to Visual FoxPro. So we can look at the file. And that's what it looks like, again, using that double chevron as the tab character and running the code just to prove that it works, brings everything in the way we expect. However, there's one anomaly, isn't there? Look at that top row. Well, that's the header row, whereas CSV knows about the header row. Tab delimited does not know about that, and so it just imports as if it were data. So one way around that, of course, is simply to use a for clause and check for the word item, which is what's in the header, and then that one will not be imported. So now we get what we expect. Pipe delimited is not one of the known types, so we have to do a little bit of special handling there. That's what the file looks like. Again, in my view, pipe delimited is a really nice format because it's very unlikely to have a pipe anywhere within a field, and it's very easy to see where the field delimiters are in this particular file. But you might think, based on the syntax of that append from command, that you could just use type delimited with tab. Well, or excuse me, with pipe. As it turns out, that results of doing that are what you might call suboptimal. This does not really give us what we are expecting at all. What we need to do is use that with character pipe clause. So you remember I mentioned that on the second use of the word delimiter in that clause of the append from command was talking about the separator. So if we do that, then we should get the result that we expect. And in fact, we do. So just a caveat there, or a heads up on what I think is a little bit of a confusing syntax because of the multiple meanings of the word delimiter. SDF file, the system data format, looks like this. Everything is lined up on the left. So the first 4 characters, or the first 10 are the date, the next 4 are the item number starting in position 11, and so forth. And again, FoxPro knows about SDF, so all we have to do is say type SDF. And that also works exactly the way we expect it to. I'm checking something here. Oh, I meant to show you something in the previous example, which was that the data did not come in the way we expected it to, and that's because the lengths are wrong. And the reason the lengths are wrong is because we defined the date as a date and the numerics as numeric. That worked fine for all the earlier examples, but it does not work here because the fields are the wrong length. So one way to handle that is to define everything as a character and bring it in that way. But now we have character values where we really wanted numerics. And similarly in the date, that's actually a character field that's 10 characters long in this case. So what do we do? Well, one approach is to add fields to the cursor that we're importing into that are the correct or the desired data type, even though we're not going to be importing directly into it. And this turns out to work fine. The input file has 7 fields. We define those 7 fields as characters. We append these other 4 that we're going to use later in a second step. And then we can bring that in. We still have character data where we want numerics, but now we have these other 4 fields that are the right data type, although with no data at the moment. And all we have to do is scan and replace with the equivalent data type. And now we have what we want. And for further processing, we'd simply ignore the character version of those fields. So that's append from, very powerful command, does a lot of what we want to do right out of the box. There is an import command also. It creates a new table. It's a little more restrictive than the append from command. Again, only handles certain types of files. Personally, I've never found a use for it. I'm sure there is a good use for it, but I don't have an example of it. You can infer from the context exactly how it works. If neither of the above, if neither append from nor import will handle what we want to do, then we have this nice rich set of low-level file functions that we can use. Open and close, everything preceded by the letter F, of course, for low-level file functions. We can open and close a file. We can check for end of file in a loop as we're reading through it. We can get data in from the string in a couple of different ways. fgetS, or what I call getString, is one way. fread is another. We'll see examples of both of those. And as far as XML is concerned, we have XML to cursor. And JSON to cursor? I don't think so. There is no JSON to cursor, sadly. FoxPro doesn't know anything about JSON. That's because JSON didn't really come along until after development of FoxPro had ceased. And so anytime we need to handle JSON, either importing or exporting, we're going to have to roll our own. But let's take a look at what we can do with low-level file functions. If we're using the fgetString command, the most basic little loop to do that would be the following. We'd open a file, whatever we want to import from. We do a loop looking for end of file. We use the fgetString or fgetS command to bring in a string one at a time, do something with it, in this case, just displaying it on the screen, and then closing the file when we're done. Notice that it always involves a file handle. Foxpro will return -1 if for some reason it can't open the file. So in most of the code that I use, there's a little trap to make sure we didn't get a -1 before we try and go on. So let's look at a demo of that. So the first example is using the fgetS command. So we're going to be using a tab delimited file. I don't think I need to show you that again. It's the same one we've been using all along. But we will fopen the file. We'll check to make sure we successfully opened it. I'd like to display that file handle in a little window in case the program ends abnormally and that file handle is still open. That way I know which one to close, although I do have a routine for development purposes that just closes the first couple hundred numbers. It doesn't hurt to try and close one that isn't open. That way you clear everything out. Once it's open, we just do a quick loop looking for end of file. We bring each string in with the fgetS command. Notice that there is an optional number of bytes, and that's kind of important. The fgetS command reads until it finds a carriage return. The default, however, is 254 characters. If you don't specify a higher value, and by the way, the max is 8K or 8192 bytes, then the read will terminate at the 254 boundary unless it reaches a carriage return first. That can be problematic if you have a file, even though it's less than 8K on each line, that is longer than 254. You will not get the whole string, the whole row of data. So it's just be common practice for me to put 8192 as the maximum. That does not bring in 1092 bytes. It just says go that far or until you reach a carriage return, whichever comes first. So that handles most cases. And then we'll close the file. This is going to display the string that we read on top of the command or the code window here. So look at this area as I run the code. Open with handle 21, and there we go. I don't know how readable that is, so let me zoom in on that. And you can see that we correctly brought in the data from our input file. So that was using fgetS. Using fread is a little different. It's the you would use this especially if you have data that's longer than 8,192 bytes, because that's the max for fgetS. So I've created a file that has something over 9,000 bytes on each line. It looks like this. If I go, this is going to jump over to the far right, and we're at column 9,224 here. This is certainly artificial just to illustrate the point, but if we turn on word wrap, you can see that there is a break. Must have passed it. There we go. Break is right here. This is all on a separate line only because it's all one continuous string, and that's how the editor shows it. So the point is we have two long lines of data that we want to bring in. And if we try and do that using fgetS, we're not going to get the result we want, even though we specify the max of 8192. What we're going to get instead is this. And again, if it helps to zoom in on that, we get 4 lines of result. We get the first 8,192 from the first row of the file. Then we get the remaining 1,031 bytes. And then similarly, we get 2 results for the second row in the file. So that's clearly not what we want. The solution in this case is to use fread, and this will illustrate the difference in the syntax. Instead of fgetS, we'll use fread, and we'll specify the exact length. So this really only works if we know the exact length. It doesn't know anything about carriage return to line feed implicitly. So the number here is the number including the carriage return and line feed characters, which ends up being 9225 in this example. And if we import it that way, then we get the 2 rows that we expect, 9,225 bytes, and only 2 rows instead of 4 like last time. So that's a comparison of fgetS and fread, and you obviously would choose whichever one is appropriate to whatever situation you're working with. When it comes to importing from XML, there's more than one way to do that. XML to cursor is built into the language, so we can certainly use that with certain kinds of XML. I'm no expert on XML, but there are XML formats that are beyond the capability of XML to cursor, in which case we can roll our own a little bit using either the XML document model or just using fgetString and string extract to pull out the pieces. So we can take a look at some examples there. First, using an XML to cursor. There's a little bit of a wrinkle here that I've run into. Look at the second line here. That's a namespace line. Not every XML file has that. There's also a syntax for an inline namespace specification, or you can get along without a namespace specification at all. So you have to kind of know what type of XML file you're dealing with that you're trying to import from, but just to point that out here. And if we simply do a standard import, and by the way, the 512 simply means that this is the name of the file we want to import. We will look at this. And that did not come out the way we expected it. We expected to get 2 rows of data. Instead, we got 1 row of not exactly what we wanted. And as far as I can tell, that's because of that namespace line. So we have a file that is identical, except this one uses the inline namespace format. And that one works fine. Now we get 2 rows of data just as we expected. And it works the same way with a file that has no namespace line at all. I don't think I need to take the time to illustrate that, but it works the same as the one above it. So again, it's a question of, as in every case, knowing the structure and the format of the data that you're trying to import in order to make it come out successfully in your program. If XML to cursor doesn't do what you want, then we can do one of 2 things. We can create the instance of the XML document object model and simply load the file and then run through the collection of elements and nodes, parsing out each one in turn, and finally doing an insert into the cursor that we created. We'll go ahead and run that code. Again, this particular line has the namespace in it, which is okay in this case. And there's our result. And the third way is even more kind of a roll your own solution, where we're going to step through the file looking for end of file. We're not using the document object model in this case. We're going to ignore the XML header line and then parse whatever else we find depending on what the string is. It's either a group header of order history, or it's an order item, or it's a field, and we just simply walk through that code. That's a little bit tedious, but you can certainly do it. And then we get the string, and let's see if that works for us. There's that file. That's our input file. And there we go. So that worked fine as well. By the way, all of this code is in the white paper, so you don't need to try and take screenshots or anything of any of this stuff as we go along. So that's XML. Importing from JSON is, you're going to have to write your own code for that. There is no JSON to cursor. You can do something like what we just did for XML using string extract or whatever other approach is appropriate. There are third-party tools out there that will interface with JSON and FoxPro. If you do a search for JSON and FoxPro, you'll find several solutions out there. One of them might be appropriate to what you need to do. I do not have an example of importing from JSON when we get to the exporting part of the session. I will have an example for you there so you can see how it can be done. Once we have our data in a cursor or a table, whatever we're importing into, then it's time to parse the data out into the separate fields. And we've already seen some examples of this as we have gone along, but I wanted to spend some time on some of the commands that FoxPro makes available to us to make that job so much easier. The first one is the substring command. If you're working with data that doesn't have delimiters, this is a great one to use. So this would be a nice example of that would be for a system data format where everything starts in a fixed position in the file or in the string that we're bringing in. And so substring just says starting at position X, return, n number of characters, and that would be each field in our string. So assuming we have an SDF file that looks like this, again, everything lined up on length boundaries, then we create our cursor. We can create each field in turn by bringing in the right length string. So for example, starting in 1 for a length of 10 is the date, which we're going to convert to a date. The item number is in 11 for 4, the description in 15 for 10, and so forth. Then we'll insert into the cursor and get all of that to work. And there it is. So that works just fine. So that's using substring to parse out the data. Another one that's very useful, especially when you're working with delimiters, is string extract. String extract knows about delimiters, or allows you to specify delimiters, and it's useful. For example, we saw that a little bit in our XML demo. I didn't focus on that too much, but we'll see that again when we talk about exporting. So when you specify a beginning delimiter and an ending delimiter and you want to pull out what's between them, the string extract is the way to go. String tran allows us to replace something in a string with something else. Lots of uses for that. One of them is when working with XML, and by way of example, we'll see how easy it is to pull out the the opening tag and the ending tag, the closing tag, by using string tran. So what we've got here is an XML file, the same one we've been working with all along. I'll show it just to make sure we're on the same page here. This one didn't have any header line. It just made it as simple as possible. So it's an order history with 2 order items in it. And what we want to do is pull out each of these fields in turn. Well, every line has an opening tag, date ordered and slash date ordered, item number and slash item number, and so forth. So our job is going to be to somehow identify these tags and the closing tag equivalent, and then pull out what's in the middle. I'm actually going to use the status line as the one to focus on here in the example. So we want to be able to create the opening tag and closing tag and then pull out the word delivered in the middle. The way this example is going to work is I'm going to create a string and then start building a message, which at the end I'll show in a message box. That seemed to be the easiest way to do this. So the first one is going to be the line that we're working with. So this is a proxy for as if we had just gotten that line with fgetString, for example. Then the opening tag is going to be using string extract to pull out what's between the left and right angle brackets, which is the opening tag. And by the way, the flag number 4 means to include the delimiters. So what this is going to return is left angle bracket, status, right angle bracket. Here's where stringtran comes in nicely. The closing tag is identical to the opening tag, except that the first character is not a left chevron by itself or left angle bracket. It includes also a slash. So we can simply stringtran the opening tag, replace the first character with those two, and we get our closing tag. Finally, we can use string extract to pull out what's between the opening tag and the closing tag. So I'm going to run all of that, and then I'll show you the message box, and we can see that it worked. I'll make that a little bigger for you guys. Sorry for the jumping around. There we go. So the line was status delivered slash status. The opening tag was status. The closing tag, which we created by stringtran, was slash status, and then the field value was delivered. So that works just fine, and kind of a side example, not only to illustrate stringtran, but also how to work with XML kind of in a low-level format. I want to mention the occurs clause. I don't have an example of it because it's real obvious what it does. It counts the number of occurrences of some expression in another expression, a string. One of the things that you always want to do when you're working with importing flat files is to validate the data as much as possible before you start relying on it in your application. One of the most basic validations is that it has the correct number of fields. In our example, we have 7 fields, the one we've been working with. So we would expect 6 delimiters, 6 commas, 6 tabs, 6 pipes, whatever it is. So occurs could be used to count the number of occurrences in each line as we bring it in. And that would be useful as a validation, except that it counts all of the occurrences. It doesn't count just those that are delimiters. It doesn't know anything about delimiters. So if we were to try and use occurs on a CSV file that had an embedded comma, as the description column did in the one we've been working with, we would count 7 commas instead of 6. We would think that there were 8 fields instead of 7, and we might flag that as an invalid line when in fact it was not invalid. So occurs can be useful, but it also has that caveat about not knowing anything about delimiters. When I first started working with incoming string data, I discovered get word count and get word num, and I thought, oh man, this is great. These are exactly what we need. Get word count allows you to specify the string you want to look at and the delimiters that are involved, and tells you how many words there are, word being, in this sense, meaning fields, for example, if it's a data string. And get word num, the companion, simply says, pull out the particular one that you want, the first one, the second one, whatever. So that sounded great, except that you should be aware that this one has issues if there are empty fields. And I wanted to show you an example of that because it can really bite you if you don't know what to look for. And again, we're going to be showing results on top of the code window, so keep your eye up there as we go along. We have a pipe delimited file that looks like this. 2 lines of data, all fields are populated in both lines. And if we open that and use get word count to get how many there are, and then to step through that number up until the total, which should be 7, and we're simply going to display those on the screen. We should, in this case, see that there are 7 fields. And in fact, it finds 7 fields, and all the data is where we expect it to be. The problem comes in when one of the fields is empty. So here's that same file, but in this case, the description field right here, the 3rd column in the 1st row, which is supposed to be a description, is empty. the delimiters are there. The pipe that separates the item number from the description and the pipe that separates the description from the price are there, but there's nothing in between. What happens if we use get word count and get word num on that file? Well, you can see where this is going because I told you what's going to happen. I better clear the screen first. And in this case, it only detected 6 fields. It just ignored that empty field. So the price ended up in the description, the quantity ended up in the price, and so forth. Clearly not a workable solution. And I don't know any way around it other than to not use those two commands as our solution if there's a possibility of empty fields. So what is the solution? Well, the solution that I've adopted is to use A-lines. A-lines reads a string and creates an array, and it does not suffer from the same problem that the get word count and get word num do. And by way of showing that, we'll take the same data that we were working with before. In this case, instead of using get word count, we're using A-lines, which returns a value, which is the number of fields, and then we'll use that value in our for loop and do the same thing we did before and show these up on top. So in the one that has all of them populated, there's no problem. In the interest of time, I'm going to skip to the second one, which has that missing description. This is the same file from last example where the description is blank. Sorry for the jumping around there. And we'll just use A-lines instead of get word count and get word num. And we should get 7 results, which we do. So using A-lines, everything came out the way we expected. Notice that the description is there and it's blank, and the price is where it's supposed to be, and the quantity is where it's supposed to be, and so forth. So that's one way around that problem with get word num and get word count. Dates and numbers sometimes require special handling. So a quick tour there just to show you what you might be on the alert for if you're working with incoming data that could include dates or numbers. Dates can come in any number of ways. I'm only showing 4 of them here. And by the way, knowledge up front that this is a United States centric based presentation. So we're accustomed to seeing dates month to year. I know Foxborough can handle other date formats, and you might get other results with other date formats. But using slashes or dashes is very common. Using the string format, the third line there, which is what you get with DTOS in Foxborough, is also very common. You might see data coming in with the month before the year, the day before the month as a string, as an 8-character string. And the question would be, how does Foxborough handle that? Well, it turns out, at least with dates set to American, it does not handle it well. Here's the file, which has the same values that we just saw on the slide. And the job here is going to be to use a append from. It's a tab delimited file. I've got an annotated version of the file that I'm using here because that way we can show the results. And if we have an input file that has a date in the form of month to year with slashes, the result is the proper date, and that's fine. Same thing with dashes, that works fine. The same thing with the string, the 8-character string with year, month, day, that works fine. The month, day, year did not work at all. I experimented a little bit with other dates, set date British, set date M or DMY or MDY, and I did not get a valid result for that format in any of them. So if you're involved in incoming data in other formats than these 4, I just recommend that you experiment on your own and see what you can get to work. If nothing works, you may have to do special handling, bring it in as a character, and then parse it out manually, kind of like we did in other examples. Similarly, numbers can be problematic, or can be seen here. Numbers in your incoming file can be any number of different formats. Here's a few that I've seen. An explicit decimal point, leading zeros with an explicit decimal point, embedded commas, which is kind of a formatted version and does not really get handled very well. No decimal point at all, which is fine as long as you know what's intended. If it's supposed to be an integer or if it's supposed to have an implicit decimal point, in which case you have to handle that separately. And even a leading dollar sign, which it turns out messes things up pretty well too. So let's see what that looks like. Again, our file is simply the same values that I just showed you on the slide. And our example here is going to create an annotated version of that same file. Let's see what kind of results we get. If the source is a straight number with an explicit decimal, everything's fine. Same thing with leading zeros, that makes no difference. If there are embedded commas, it doesn't work at all. It stops parsing it as soon as it gets to the comma after the number 1. And so that's not okay. This one is okay, again, as long as you know if there's supposed to be an implicit decimal or not. Is that 123,465,789? Or is it 1,234,567.89? You just have to know that. Sometimes data will send it to you that, or files will include data that is represented that way, even though the decimal point is implied, in which case you have to divide by 100. The leading dollar sign just doesn't work at all, even if you define it as a currency field in your cursor. So a quick trip talking about dates and numbers, which may require special handling. So now we're ready to move on to exporting data, which of course is simply the flip side of importing data. So in this situation, you're responsible for a visual FoxPro application that uses data. However it exists, at some point it's going to be in a cursor or a table, and you want to export that to one of the many different possible types of flat files, presumably to send on to some other system that then will consume that data for their own use. So whereas in the importing side, we had the append from command, FoxPro on the exporting side gives us the copy to command. And like the append from, it can handle many different file types, but again, not all of them, and certainly not any of the newer Excel file types. So it's useful up to a point. Beyond that, we may have to roll our own with low-level file functions, which we'll do in a minute. But the copy to command has the same clause that the append from did, and that's that delimited clause. And that'll become important depending on the type of file that we're wanting to create. So let's see some examples of that. The first one is going to be using, that's copy to. So I've got several examples of that here. Our incoming DBF, so now this is flipped. Now we're reading a DBF, a table, and exporting to some kind of a flat file. So let's look at what that table looks like. As we've been seeing it all along on the output side, now it's going to be our input. Type delimited is one that's built in. If we simply use type delimited, it looks like this. Notice that there are quotes around the string fields. It's comma separated. This is essentially a CSV file. So that's pretty nice. We can say type CSV explicitly. The difference there is going to be that we get a header row. So this is the more formal CSV definition that includes the header row. We can say type delimited with tab. FoxPro knows about that one built in, so that'll look nice. Again, the chevrons representing the tab character. It does put quotes around the string fields. Now, suppose we want to create pipe delimited file. You might think from the syntax, at least I thought from the syntax when I first started working with this, that I could simply say type delimited with pipe. Seems right, doesn't it? Well, guess what? You learn something new every day. What did I do wrong here? Want to reload it? Yeah, that's fine. Notice that at a glance it looked right, but it's not. There's commas where there don't need to be commas. There's pipes surrounding the fields, so kind of being used as that kind of delimiter instead of a separator, just not the correct value at all. So it's not what we wanted. However, if we use type delimited with character pipe, that's that second use of the word delimiter in the syntax of that clause in the command syntax, then we get something closer to what we want. But we still have quotes around the strings, and we don't really need that. We don't really want them there. So here's where we get into using both of the parts of that clause, delimited with blank, meaning nothing surrounding them, and separated with character pipe. So again, maybe not the clearest syntax in the world, but once you learn how it works, you can use it, and this works just fine. And now we get the file the way we would expect it to. No quotes, no commas, everything nicely formatted with pipe delimiters the way we wanted. So that's copy to. If copy to isn't good enough, we have low-level file functions for exporting data as well. They're simply the corresponding ones to the ones we used for importing. Instead of opening, we create. Instead of getting or reading, we use put string or write, and I'll illustrate the difference between those. There's a flush command,fflush, that says if there's anything in the cache, make sure it's been written to disk before you close the file, and then there's a close. There is also a built-in cursor to XML. Sadly, there's no cursor to JSON, but I will show you an example of how to create JSON using low-level file functions. The structure of the code would look very much like this. We'd select whatever input DBF we're working on. We'd create a text file, specify a delimiter, build a string, use a single fput string for each line. And by the way, fput string adds the carriage return line feed at the end automatically. You do not have to worry about that. And then after the scan is done, you close the file. So let's look at an example using fput string. Again, our input file is the same as it was, so I won't bother to do that. The loop is simply going to be creating a string, appending each field as we go along, and using a single fput string to write the file and then closing it and showing what that looks like. Well, it didn't. What happened there? I'm getting a window on my other monitor that I didn't expect. Oh, I know what I did wrong. I got to run the whole thing here. Sorry about that. So there's our input. And it failed to create the file. Why did it fail? Probably because I have it open. Well, let's close everything and try it again. There we go. That was a case where I had the low-level file was still in use because I had to cancel the program the first time. So that was where that was useful to be able to know which one I had to close. Anyway, this creates our file the way we expected. So how would that be different if we used fwrite instead of fput string? Very much the same thing. The big difference with fwrite is that it writes whatever you tell it to and does not include a carriage return line feed. So in this situation, we are going to be fwriting every single field And then at the end, we are responsible for adding the carriage return line field. Remember earlier when I talked about line breaks? So here is where if you're creating a file for Unix or you're creating a file for Mac, you would have to create or write the appropriate line ending character rather than always necessarily assuming that it's Windows. So let's see what this looks like. And here's the code, same input file. Here's our loop. Here's an F write for every single field. It just continues to write to that string that eventually we're going to add the carriage return line feed to. So this is like an output stream, I suppose you could call it. Again, our delimiter is a pipe. So let's go ahead and run this. There's the input file. We created the output file. And there it is. The reason we're getting that flashing on there is because I had copies of these files from when I rehearsed this session. So that works as well. It's just the big difference is that in this case, you're writing for each individual field, where with the put string, you're writing once and it adds the carriage return line feed automatically for you. Exporting the XML is pretty straightforward. I'm going to show you an example of cursor to XML. I don't have an example of rolling your own with low level because I wanted to reserve that time for showing you how to do it for JSON. So let's look at an example for cursor to XML. Very straightforward piece of code. Again, our same input file that we've been working with all along. 2 rows of data. One of the things to point out about the cursor to XML command is that it has 3 different formats that it can create. And that's what the value of this flag is here, 1, 2, or 3. The element centric is the one that I think most of us are most familiar with. I've never really had to work with the other two. Again, I'm not an XML expert by any means. I've had to work with it a little bit, enough to be dangerous, I guess. But if we create it in the standard format, or format number 1, I shouldn't say the word standard. It's the one I'm most familiar with, the one that I think most of us recognize. There it is. So it's got a header and then our hierarchy. Again, these are tab characters just being displayed by the editor. Just to illustrate the point, the other 2 types, here's type number 2 and type number 3. If you need the formats, I don't know what those formats are used for. I've not encountered those in actual practice, but just to point out that they do exist in the syntax of the cursor to XML command. Again, saving our example for JSON, I want to move on to that. So we have no cursor to JSON, meaning that we can't do what we did with XML. What we can do, though, is create our own. And again, FoxPro makes this so easy because we have such great tools at our disposal. The other choice, I suppose, would be to use a third-party tool. And just as on the importing side, there are tools, some community-based, some commercial, that can help us in exporting to JSON. But it's not too difficult, at least not with a fairly simple JSON format. And I have had to do this with applications that I've worked on and created, and it works just fine. We've been able to create the JSON that the other end wanted to consume. Most likely that could be a web-based app, because JSON is mostly used, or a very popular way of handling data in web applications. So let's take a look at that. The code is going to be very much like what we've been seeing before, except, of course, the structure is going to be totally different. Our input file is the same that we've been seeing all along. That's our 7 fields in an order history table. JSON uses indentation. 4 is common. 2 is also used. 2 is certainly better for presentation because it just doesn't have as much white space and stuff doesn't fall off the right side of our available screen space as much. So I'm using indentation of 2, 4, and 6 in this example. And then we need a couple of counters to know how far we have to go in the file. So we're going to create a file called orderhistory.json. That's our if create here. And then we're just going to start writing strings. And since we're using fput string, every one of those is going to be terminated with a carriage return line feed, which means that when we look at it in an editor, each one is going to be on a line by itself, and it's going to be nicely readable to us as human developers looking at it. So we simply go through a loop, scanning through the order history table, writing each piece as we go along. And again, in a format like JSON or XML, each line is either a descriptive or a container of some kind, or it's an individual field, unlike the others where each line is an entire row of data. So we're going to put S for each of the pieces that we need. The only thing at the end is we do not need that trailing comma. So if we're up to the end of the file, we write the closing brace without a comma, otherwise we write it with a comma. And finally, we have to write the closing syntax, and then we'll take a look at the result. So I'm going to highlight this entire chunk of code and run it. And we created the file with file handle 27, and there's our JSON. There's more than one way to represent this data in JSON. This is just one choice that I made. For sake of illustration, it's similar to the actual data that I had to create in the actual app that I was using this for. So that's it. That's all you have to do. Again, the power of VFP, either its built-in functions or these low-level file functions, is really astonishing. It's great that we have all of these tools available to us, and we can do almost anything that we need to do. In fact, I have never found anything that I can't do one way or the other. I want to close up with a few minutes on Excel, and it looks like we may have time for questions even within our hour and 15 minutes here, so we'll see what happens when we get done with this section. Again, Excel is great. Almost everybody likes Excel. My end user community likes Excel, I should say it that way. Most of the people in any kind of a quantitative role or analytical role working for my clients uses Excel in one way or another. I've been asked to export to Excel from Visual FoxPro applications some pretty involved spreadsheets. And again, because of FoxPro's capabilities, it's, although tedious, certainly possible and easy enough to do that sort of thing. On the flip side, I've encountered situations where the end user has what they consider data in an Excel spreadsheet. Sometimes they even get that data from a third party. So somebody that they work with will send them a spreadsheet. That spreadsheet has data that they want to look at and then pass on to the application, the FoxPro application that I'm involved in using. Well, that can work, but it also can not work. So my mantra is Excel is not data. That's a little bit too strong. The reason Excel isn't data is because users can mess with it. And so let me soften that a little bit by saying that it isn't necessarily a reliable source for importing data because users can make changes to the spreadsheets. And they love to make changes to the spreadsheets. And here are some of the things that I've run into over the years when being on the receiving end of data in the form of Excel. Typically, you won't get the Excel file itself. You'll get the CSV export version, and that's what we're going to be using by way of example here. So here are some of the things that I have found that users like to do in Excel. They like to add or remove header rows. Well, that's clearly going to mess up your import if you're creating a CSV file from that spreadsheet. They like to move columns around. oh, gee, this one's way too far off to the right. I can't see it next to the one that I'm interested in. I'll just slide it over. That also clearly is going to mess up your import. Things like adding subtotal lines. Again, Excel, so powerful, can do so many different things, including that kind of thing, adding subtotals, but that's going to mess up your import. And this last one is really kind of insidious. It took me, I hate to admit, more time than I'd like to admit to figure it out the first time I ran into it. Did you know that you can use Alt-Enter within a cell to create a line break? Well, you can. And I had some very creative users who discovered that and decided to use it. But this was a file that was going to be exported to CSV and then imported into my FoxPro app, and it caused all kinds of havoc. So let me illustrate what's going on there. So I've got a couple of spreadsheets, and I'm going to simulate exporting them to CSV and then see what happens when we run it. So first of all, I need to create a shell object here. And then I'm going to open this first spreadsheet. And that's what it looks like. So what I'm talking about here is a field like column H. Column H is a notes field. The notes can be quite long. I'm sure many of you have seen users working with Excel spreadsheets like this. And if there is a column to the right of the field that can be a long note, then the note doesn't extend into the field to the right. It gets truncated. And the way that that's most frequently handled is by wrapping text, formatting that cell to wrap text. Well, that works fine. There's no problem at all with what you're seeing here. And to show that it works, I'm going to use Notepad in this example instead of the editor that I have been using because it shows this a little bit better. So let me run that first. What it's doing is opening this orderhistory.csv. That's the file that was exported from the spreadsheet that we just saw. So let me run that. And I think, there we go. So that looks good. So we have our header. That's fine. We expect that in the input. It's been programmed for. And then we have 3 rows of data. Well, that's what we saw in the spreadsheet, right? We had 3 rows of data and a header row. So everything is good there. And Excel, our FoxPro app will handle that just fine. We're creating a cursor with fields for each of the columns in that spreadsheet, and we're using append from type CSV, which we know works. And we're going to append from that CSV file. And we got 3 rows of data, exactly what we expect. So everything is fine. The problem comes in when our user gets creative and does something like this. So I'm going to open a second copy of that same spreadsheet. And now look what happened in column H. The user wanted to add a second note. They did not want that second note to be right up against the end of the first note, which is where it would be if they just started typing 08/21/2014 right here. So what they did was to hit the Alt-Enter key after the period, after the word again, and then write the rest of the note. Well, that's great. What a great solution. It looks just fine in the spreadsheet, makes it easy to read. Every note begins on a separate line, but it really messes up our import because, as you can foresee, what happens when we get to the CSV file, which of course the user is not going to pay any attention to. They're just going to export it and send it to us. Now, instead of 3 lines of data, we have 4. And this third line is the second half of that note. And the reason it's a separate line is because there is a carriage return line feed at the end of this line. That's the end of the first note, that again, period, word. And so now we have a 4th line where the 3rd line should be. And of course, when we try to import that, we're creating the same cursor and expecting the same type of data. we get this funky line in the middle. Well, these are the kinds of things that you discover at runtime. So when this first happened to me, I was pretty hard pressed to figure out what was going on. And I had to go back to the user and get a copy of the actual spreadsheet to see how they did that. And once I found it, it was obvious. And, there's really not much way around this except a little bit of training to say, hey, please don't do that. Or, doing some contortions in your code to try and detect that sort of thing. So that's an example of what can go wrong with Excel and is the reason why trying to find the slides here. There we go. That's the reason why my operating mantra is Excel is not data, which means really just be careful with it. So we're done. What we've been today is we talked about what flat files are, including things like XML and JSON, the important distinction being that they're strings, and Excel being, Foxborough being very, very good at working with strings, importing them, parsing out fields, exporting data to flat files. And then we finished up by talking about the kinds of things that can potentially go wrong with Excel. So thank you for your attention. Please do fill out your evals. We have about 5 minutes here, I think, tomorrow. If you want to take questions in line now before time is up, that would be fine. Otherwise, I will see you in the Q&A session, and this is how to get a hold of me. So
yeah, sorry, I didn't mean to interrupt.
Go ahead, Tamara. I'm done.
There are a lot of stuff got hashed out in the chat.
Okay, good.
Your editor looks like Edit Plus. Can you say a bit about how you ended up with that one? Looks nice.
Of course, yes. Thank you. Edit Plus is one of the early ones that I used before I was aware of Notepad++. The main reason I chose it is because it has a community-developed template file for Visual Foxborough. So it does some syntax coloring. It's not identical to what Foxborough itself does, unless you monkey with the colors, the default colors. But it's kind of nice to have some coloring because it makes things more readable. The other nice thing, although other editors like TextPad also have community-developed syntax files for Foxborough, the nice thing about Edit Plus is that you can create a new file and tell it immediately that it's going to be a Foxborough file before you save it. Other editors don't necessarily know how to do that. It doesn't take on the syntax coloring until you save it as a PRG or whatever. So that's another reason I like Edit Plus. Notepad++ is a standard too, and I have not yet found a syntax coloring file for Foxborough in Notepad++, but it is also a very good editor.
Okay.
Does that answer the question?
I think so. And this one, I guess, was, hate to say it, more of a comment than a question, just pointing out that when you were talking about ways to read the data in, you didn't talk about file to string and string to file. And I'll say that I habitually use file to string and then A-lines to break up files. Good
point. And no, I did not include those in this session. There are other commands that I left out, like left, right, rat, hat. There's a bunch of them that can be useful in parsing, but file to string and string to file certainly very good and could easily have been part of this presentation. Thank you, whoever made that comment.
Okay, and that was all we had.
Okay, super. I guess we're done. Thanks, everybody. Hope you had a great conference. I enjoyed being here today. Hope you did as well, and look forward to talking to you. Tomorrow, is there a Q&A session or not?
Yes, there is a Q&A over in the sessions area, and we'll get Rick there soon.
Okay, I'll jump over there soon. Thank you.